Okay, so we're on 2018 FRQ number 2, and this is still the calculator portion. It says a particle moves along the x-axis with a velocity given by v of t, this awesome formula here, between t equals 0 and 3.5 seconds. The particle is at position x equals -5 at t equals 0. So that's the initial place, initial position, right? So it says find the acceleration of the particle at time t equals 3. All right, so time t equals 3. So part A here, again, this is a calculator portion. So really, it's not necessary to do this on your own, like do it by hand. You can actually use a calculator to help you. So we're looking for v prime because that's your acceleration. So acceleration equals v prime. So we're looking for a of 3. We're looking for v prime of 3. All right, so again, to use our calculator to help us, let's go ahead and put that in. So it's math 8, that's a derivative, right? d dx of our function. All right, this is a really nice big function here. So this formula, this function of, all right, this whole thing is on the numerator, so make sure you put it all in parentheses, all right? So 10 sine of 0.4 t squared, parentheses, divided by my denominator of 10 t squared minus t plus 3, close parentheses, and we're evaluating this at x equals t equals 3. Okay, enter. All right, beautiful. We get negative 2.118. All right. So my acceleration, let me see if there's any units here. Nope. So acceleration is negative 2.118. That's it. Nice and simple. All right. Next, find the position of the particle at t equals 3. So again, we start with our initial. So the position equals, we start initially at -5. That's where my particle is, right? And then position is plus the integral of velocity, 0 to 3, and that would be our v of t dt. Okay. All right, so we're going to put it into our calculator. And again, you can see this from the first problem, so I'm not going to go over this again, but it will be math 9, putting this integral in. So that'll be -5 plus 3.240, which gives us negative 1.760. So again, this position doesn't mean it's negative distance. It just means it's to the left of the starting point instead to the right of the starting point. All right, so position is negative 1.760. Okay. Part C says, you're going to evaluate from 0 to 3.5 v of t and evaluate the absolute value of v of t from 0 to 3.5. So what's the difference, right? So 0 to 3.5 v of t dt, putting in my calculator using math 9, I will get 2.844. If I plug in 0 to 3.5 absolute value of v of t dt, I would get 3.737. So what's the difference? Interpret the meaning of each of these in the context of the problem. Well, this is displacement of the particle in the interval of 0 to 3.5 seconds. This is the total distance traveled by the particle in this interval between 0 to 3.5 seconds. So that's the difference between those two, right? So remember, the absolute value makes all the areas positive. So that's why this is a total distance instead of just displacement, because it doesn't cancel out. All right, last part, let's look at D. D says, a second particle moves along the x-axis with a position given by x sub 2 of t equals t squared minus 1 for 0 to 3.5 seconds. At what time t are the two particles moving with the exact same velocity? So you want the two velocities to equal each other, but this one's a position function. So the velocity of that, v sub 2 of t, is a derivative, so that would be 2t minus 1. And you're going to set it equal to our other v of t, which is this v of t up here. So you're going to set the two equal to each other. So you're going to say 2t minus 1 equals that awesome function of 10 sine of 0.4 t squared all over t squared minus t plus 3. So yes, use a calculator and I will graph both functions. All right, so go to y equals, go up and clean all this up. All right, so the first equation was 2t minus 1, beautiful. The second equation was parentheses 10 sine of 0.4 t squared divided by t squared minus t plus 3. All right. And I'm going to graph this. Oh, this is awful. So I'm going to zoom in a little bit more because I want to see where they cross, and it only crosses at one point right there. So my intersection is at 1.571. So that is exactly when the two velocity are going to be equal to each other. And that's it.